all set here. So this might change. So hello, my name is Christina. Yeah, there we go. Hello, minibar. Wait for it. There we go. And I'm here to talk about the Tweetskirt, which is a skirt and hardware. So my name is Christina. I'll stick to the script here. And I am a front-end developer by day, and I play with hardware at nighttime, on weekends, and whenever I can. So this was an animation in case the skirt didn't work, but it does, so you guys get it twice. I never got an electrical engineering degree, so all of my hardware stuff has been through playing around and through help of my dad and the Arduino open hardware community here in Minneapolis. So as I tell people, I spend money on hardware, I don't make money on hardware. And so I'm going to be going over my experience building a skirt that can receive and display tweets and the server that both pulls Twitter and allows for moderation. So there are 3 parts to building a Tweetskirt. I'll be going over all of them. There's the hardware part, both constructing the physical LEDs, Arduino, wiring, whatever. The server that, like I said, pulls Twitter, gets tweets in, lets you select which tweets you want to display, and then the actual design of the wearable garment. So I will start out by going about the hardware side. So this is just a picture of the hardware that's in the skirt when you take it all out. It is all removable, so that way I can throw the skirt in the wash, and it's completely fine. So it's pretty simple. There's a battery. It's just one of the RC car batteries. That battery's exports, I don't know, whatever you say, it spits out 7.2 volts. And there's a voltage regulator, which sounds really complicated, but you just buy them on eBay. And then they have a little dial that you can dial down the 7.2 volts to 5, which is what the LEDs need and what the Spark can handle. And I'm using a Spark core, which is sort of like an Arduino, if you're familiar with that. I see we have some Spark people in the audience today. Hi. And it basically is unique in that when you plug it in, it gets power, it looks for wireless, you set it up with a wireless network, and it just sort of lives on the internet. And it's really, really helpful for people who normally do front-end development to be able to have it interact with the web. And then the LED array, or the LEDs on it are using WS2812B, which is standard, more commonly known as neopixels for the LEDs, and then they're constructed in a rectangle, which I'll describe how to do in a second. And I'm using, I'll go over that more later. So the basic wiring, this is my artist rendering. I hope you enjoy it. Thank you. I just wanted to show kind of how the wiring works because it's a little hard to see in a photo. But basically, when you get the power out of the battery, it goes to the voltage regulator to dial it down to 5 volts. And then it splits off. And one of the splits goes into the Spark to power it, and then the other split goes to the LED array directly, just because the LEDs take a lot of power, and you can't expect that all to go through the Spark and to the LEDs. I don't know exactly, this is like how electricity works is one of my biggest non-knowledgeable areas when it comes to hardware, but it hasn't exploded yet, so doing pretty good. The strip LEDs that I use, if you're going to buy strip LEDs, I would really, really suggest you look for the 2812B or 2812 LEDs. The NeoPixel library is one of the most commonly ported to other platforms, so I think it was one of the first that Spark had, just because everyone loves bright, shiny objects. And they're very flexible and light, these strip LEDs, and you only need to worry about soldering the ends of them rather than soldering each individual LED, which is good for saving time and for durability. And yeah, they're very, very flexible. I took the 2 pictures there, kind of show you can get them really wide spread apart or really condensed together. And so the Tweetskirt uses the one that's less condensed there. It's the 60 LEDs per meter, but I think the other one is 144 LEDs per meter, if that makes sense. And you can use that if you really want if you want a lot of LEDs. So to make an LED take it from a strip like that to the rectangle like in the skirt, the way that the NeoPixels work when you program them is they all have each LED on the strip has an address. And when you clip them apart and kind of piece them back together to fold back up on itself, you can use a little math to be able to say, all right, well, each of my strips is 4 long. So you can give it an XY coordinate and it'll spit back out a address from the LED. So one of the first functions that you write is just making sure that you can have it calculate out an LED address, and then you can just sort of use that to draw everything else. So to power the LED array, because usually with these ones, you have like those little arrows in that top, another artist rendering, is both the power and the data line. But you really only need to give power to each strip. So the way how that's done to kind of make that easier is I run the power line and the ground line perpendicular across the whole thing, and then have little wires that go up and connect to each strip, because you just need to make sure this strip itself has, you don't need to connect power and ground to each end, so you can just do ground on one end and power on the other. And liquid electric tape, which I did not know is a thing until someone told me, and I was like ready to hug them. But liquid electric tape is the best way to insulate those T intersections, because you can't really use like heat shrink tube or anything like that. And then I wanted to bring this up too. I didn't use this in the Tweetskirt, but if you want to build wearables and you don't want to have a lot of LEDs, you don't mind soldering each one individually, these LED sequins were another thing someone told me about, and it was like, this is amazing. So you can get LEDs in like a sequin form, and you do have to solder each one individually, but they're on like an actual little board, and they have these really nice big solder pads, so you don't have to be, you can have a little bit of shaky hands when you're soldering. So I will go next into programming the hardware part of this. So the first challenge when it came down, so I built the array, and I was able to send and light up specific pixels on the array. And I wanted to be able to do letters for the tweets to show up. And I decided that how I wanted to have it built was the hardware would handle all of the display. Like you can just send it in a string, and it would construct everything it needed to do to just display it, rather than have like sending it instructions on what LEDs to light up. So to store it all, that means that all of the characters I wanted to display would have to be stored on the hardware. And so one thing that's kind of neat about Arduino or Spark programming is when you have a character and you use it as an integer, you can have it reference, instead of it like, this is a little hard to see, but like the ampersand here is 38. And so if you are using it in the context where it's expecting an integer, it will show 38 instead of the ampersand. So that makes it easier for programming. I don't remember where I was going with this, but yeah. It does make it easier, I don't remember how. But anyway, so to display the various characters, the beginning of the program is just like, it just shows all of the different characters. I had it programmatically put out whether it's that's a S, and then whether it's the LED is on or off for like the white space or the actual S. And that's just stored in binary. And to save a little space, you can condense 3 binary characters down to 1 octal character. And then so that way the computer only has to store 4 characters, or 2 characters instead of 6. So I do this for every single character in the ASCII table that actually is a character, not just some sort of white space. Then to loop through, actually let's just go through, I'll show you. I gotta put the mic down. That's pretty big. So yeah, like the beginning of this program, you can just see it's just all the characters all spelled out with binary, and then the appropriate, because you can do string conversion to have it be to turn that octal into binary and then pick out the right character. So there's a function that takes care of that. So I'm going to really kind of skip over this, because it's the looping through to actually animate the thing going across. It was one of those things that I figured out finally at like 2 o'clock in the morning, and once it got working, I'm like, I never want to touch this again. So, but basically how it works is when you have your string of characters, there's like this box of all of the ones and zeros or whatever that's making up this string of characters. And like every little like snapshot on this is like one window. So you have that window and you draw all the characters in that window. Then you move the window over one and you draw all the characters in that window. And then you get to the end and then it starts back over again. So it's a little hard to explain, but honestly it's all written already and the code is all open source. So don't write it, don't figure it out, just use my code. It totally works. But yeah, it was like, after I got this working, because like I said, I'm not a hardware programmer by my job. I'm a software, I do like web apps or whatever. This was all a lot more complicated and mathy and whatever than I was used to dealing with. So, but once I got this working, I'm like, this is actually gonna get built. And I mean, this project it sat on the shelf for like a year, like, because I first got into, all right, I can store these characters as octal. Now I need to figure out how to animate them. And I'm like, overwhelmed. And then I would look at it again a few months later and be like, I cannot. And then later, like, nope, I still don't know what's going on. So, but there came a time when I was explaining it to someone like months later and I'm explaining like why it was hard for me to figure out. And then I was like, wait a second, I can explain this in a way that I can program really easily, and it just clicked. And that's when I knew that the Tweetskirt was going to be a thing that exists in the world. So So with this, I had scrolling text up working. I could just type out something and it would scroll. And I needed to figure out how to make it interact with a separate app. So this was all running on the Spark core at this point. So the Spark has this really, really cool function called function, where basically this is directly from the Spark docs. Thanks for writing this. But you basically, in the Spark code, you set up a function. So in this one, it's called brew coffee, and you can say, all right, Spark Cloud, I want you to know when someone calls the brew function from a REST call that I want you to call the brew coffee function and do all the hardware stuff. That would be turning on the switch or whatever to make the coffee do the coffee brew. So, and then this bottom part, if you're a web developer, you're gonna see that a lot in your work. It's just a regular REST call, and you specify the device ID to your specific core, Spark core, and then the access token, and any arguments you wanna pass in. And you can see on the end here, it says brew, and that's what gets picked up by the Spark, spark.function brew in the setup of the Spark core. So that way I can just call it from any sort of web application, anywhere where I can send a REST call, and it will actually do something in the real world. So I was really, really excited about this. Yeah, spoilers. And then I was like, okay, I can do this REST call, and it's gonna be great. And then I'm like, the argument has to be limited to 63 characters. And no. And I know there's ways around this, but I really like to try to make the hardware part as simple as possible. So I know there's a way you can turn off that limitation, but instead I just wrote it like this, where instead of sending one REST call with the string, you send a begin, there's like you pass in a 1 or 0 first for if it's an admin message or not. So you pass in it's an admin message of begin, and then you pass in 0 and then all of the messages that you want to pass in. And then the end it, admin message end. And it will concatenate all of those other messages together and send it out to do the scrolling. So that's how you get around the 63 character limitation. And I would handle making sure that this argument was under 63 characters in my JavaScript code that was sending the REST calls. Is this all making sense so far? All right, good. So yeah, so the REST call with begin would come in. It would just send in all the messages. I just explained this, but I'm getting ahead of myself. And then the end one would go. And then in the rest of the Spark code, like the rest of kind of the overhead functions, there's really just 3 things. There's the scroll thing that just does the animation with the window that moves around. There's the set LED, which is where you pass in an XY coordinate and it figures out the address for the actual pixel of the array. And then the get char pixel is what you say, okay, I have the S character, I'm looking this many left and this many down. Is it a 1 or a 0 to see if the pixel is on or off? So with those 3 things working together, that's how you can get you can send in messages, send in text, it will scroll, concatenate all the messages together and then scroll that text across the LEDs. So at this point, I was sending REST calls and from, like, not Twitter or anything, but just like from Postman. and just like having a really great time displaying messages on my skirt. But the end goal was always going to be Twitter, because that's where the end goal is a lot for me these days. So it was up to how would I make it interact with Twitter, and most importantly, because I was when I got into this, it was really I went to GDC this year. Yeah, GDC is a big game developers conference in San Francisco, and when it kind of was going to work out where if I really crank this through, I can be able to get this done for GDC and wear it in the expo that I was in for and tons of people would be able to see it. So I was really driven to get it done with GDC. But with a Twitter interactive skirt in a really large place, moderation became a very big goal of mine. I definitely did not want the world to have free access to things that would appear in my clothing. So the server was going to be not just getting tweets in, but letting me be able to choose what tweets get selected or not. So that whole system, again, all of this code is online, and so I'm gonna go over kind of the architecture, but I'm not gonna get too much of the code. It's not that complicated. There's two main programs that run. The first one is bot.js, and that just interacts with the Twitter API to grab tweets in either from the hashtag Tweetskirt or to the Tweetskirt user, which I registered, and it just gets those tweets, puts them into this tweetqueue database. I'm using AnyDB, which is I guess kind of like a stripped down Mongo for Node. Yeah, this is all running on Node, by the way. I didn't say that, but JavaScript and Node. So it just puts it all in that database, forgets it, just keeps, that runs every 3 minutes. It's looking for more tweets to display. Then the other part of this is an Express server, which has a login API, an API for the login and for being able to grab tweets from both the tweet queue that puts it in. There's three of these files. The tweet queue, which tweets go into, the display queue, which is when you've decided to display a tweet, you put it into the display queue, and then that's what the skirt is looking for every minute to be able to display tweets. And then after a tweet's been displayed, or you decided that you do not want to display that tweet, it goes into the displayed tweets. I used really great names here, but I couldn't think of anything better. Yeah, and so there's an API for logging into, and I got SSL running, so I want to make sure nobody hacks my moderation. I don't trust anyone at GDC. So anyway, yeah, good, careful. The end goal, I use Bootstrap because Bootstrap, and it looks beautiful. But this is what kind of the interface looks like. When tweets come in from the bot, it puts them in that blue display queue at the top. There are two buttons, display or remove, and that will either decide whether they go into the green display queue box, which is what the skirt's pulling from, or the red one on the red box in the bottom, which is if it's remove without displaying, they're just black. If it did display, it's green, and if there was some sort of error, it shows up as red. So that Express server both pulls in data from all three of those files just to display what's inside of those files. And then we'll let you move a tweet in, actually just pulling one in and then deleting it from the old one and putting it into the other files. And it also, that Express server serves this static page that actually is displayed. Do you have any questions so far with this, getting to the server part? So the last part of this is the bot again. So along with every 3 minutes pulling data from Twitter, every minute it pulls data from that middle file and says, okay, here is a tweet that is going to get displayed. And it does all that Spark REST call stuff that I just described to be able to get it to display on the skirt. And then once it's done displaying successfully, or it gives it 3 tries. If it times out or there's some sort of error, it has an error count, and after 3 times of getting errors, it will just put it in the displayed tweets as something happened here, something bad happened. And so yeah, then everything ends up in the displayed tweets, the last one, after it's done. So kind of the architecture to run all of this, I'm using the $5 a month DigitalOcean node droplet because it's super easy and nice. I'm using the node library forever to queue up to have those two, the bot and the Express server, run continuously. That Forever is super nice to use. It's really easy, and it also will all of the console logging that I have just goes to a file, and Forever manages that log system too. I have the Galicia.com domain, so I just pulled up a subdomain and registered it, put the DNS magic, so it's Tweetskirt, tweetskirt.galicia.com. I'm using StartSSL for a free SSL certificate, so that way when I log in, it's encrypted, and I don't have to worry about someone sniffing that traffic in a GDC and hacking my moderation system. The Spark for kind of sketchy conference Wi-Fi is just tethered to my phone. And I'm going to sound a little bit like a T-Mobile shrill with this, but T-Mobile really did me a solid with their 10 gigs of free data this year. They had this data stash promotion where if you paid for extra data for a T-Mobile plan, they just gave you 10 gigs to use this year. And I'm going to be using most of that by the time this year is done. Just because it's tethered on my phone now. It works pretty well. Tweetskirt, yeah, it's still running, hooray. And so with all of this in place, you too can take Tweetskirt bathroom selfies. And that's me at GDC, just I was soldering in the expo hall. Well, no, I think it got there okay. It broke. I went to a party and it broke during the party, and so then I had to bring my soldering iron out in the expo hall before anyone was there the second day. But it lasted the trip to San Francisco, which I was excited about. So the last part of this, and I am really fast, is the wearable design part. There's a few tricks to be learned after all of the technology and hardware, just that are kind of specific to putting LEDs in clothing. And so firstly, this isn't going to apply to a lot of you, but if you are interested in putting LEDs in skirts, I would really recommend circle skirts, just because, that's what this is, and they're really simple to make and modify. You don't need to have a pattern. You just put some fabric on the ground, you figure out your waist, and that's your inner circle, and then you do some math to get the outer circle, and you cut out this donut of fabric, you hem the bottom, you put elastic on the top, and you're good to go. So it's really, really simple, and you can just modify it, and it looks cute. And so if you like skirts, I would recommend doing circle skirts for hardware projects. And really for any other thing, just trying to figure out the simplest possible way to get your initial idea out there, because you can have your final thing be beautiful and perfect and complicated, but you're going to be doing modifications based on how things weigh, how things lay, how the hardware kind of fits into a garment. So just really starting simple and kind of, even if you just know it's going to be a prototype, and building off on your really fancy thing later is really the trick there. So the second little trick is having to do with how to diffuse light through fabric. So this is done through trial and error, but when you don't have a cover on LEDs, the light looks a little pointed, and it's hard to tell what a shape is, and it's really hard to tell what a letter is. When you put a black cover over it, because I wanted to do the black fabric over it because it just kind of looks cool, but when you put black fabric over LEDs by themselves, the black fabric absorbs that light, and it's really hard to tell what shapes are, and it's hard to tell what letters are, and everything just kind of looks like this blob, like these little LEDs that are kind of moving around, and it's hard to tell what the actual thing is. So putting a terry cloth, white terry cloth or a towel over it, really helps diffuse the light. But I don't know about you guys, but I'm not wearing a washcloth for a skirt or a garment. That's really ugly. So but the white terry cloth does such a great job of diffusing that light that even if you put black fabric over that, if your LEDs are bright enough, it still diffuses the light. When the black fabric absorbs it, it still does a really good job of just having the light be diffused and look kind of cool. So that's what this is. I'll cover this later, otherwise I might break it. It'll be fine. So, well, maybe not. So yeah, this is a good picture of it. Nice job. I really did a great job with this slide. You can see how that's the back of the LEDs. So the LEDs face the terry cloth, and then it goes through that, and it's just sewn on the back of this skirt. So that's what this little, you can kind of see the stitches if you're close enough, but that's where the panel, the terry cloth panel is, just applied to, sewn right to the black fabric there. Um, yeah, so the second part that kind of came about with this is, so I've done a skirt before with LEDs in it. It was about a third of this size, and with the larger LED array, I had a problem with it staying next to the fabric. Once the LEDs sort of back away, you get it gets a little hazier about, like, I'll try to, but you don't see it as well once the LEDs are farther away from the fabric. And with the weight being heavier, since it's a larger array, like the tendency of it would be to back and kind of fall away from the fabric. So, and then there was a hard part of trying to place that large LED array into a pocket without it bending and kind of breaking and getting weird and getting caught up in the terry cloth or whatever. So there's two things that are kind of fixing this. One is I put zippers on either side, so that way when, so on both sides of it, I can just kind of unzip the whole thing, place the LEDs into place, put them into place, and then zip up the sides and then snap the top, and that really, really holds them secure and nice against that fabric. And it's not too heavy, and it makes life a lot easier. The zippers are plastic and not metal, just so they don't touch any of the metal parts. The snaps are metal, but that is far enough away from the electronics that it's not a problem. And then the spark has its own little pocket off in the corner, and its own little snap to keep it kind of in there, just so it's held in place. One thing that I did run into with this is you need the data line. So the line between the spark and the LEDs that gives it the data of what LEDs to light up needs to be as short as possible. So you want to try to keep, because otherwise you get interference and you get weird, like, different colors, and it looks kind of like a disco show, which is cool at first, but then it gets really, like, not cool. So you want to try to keep it short, and having the spark be, like, right there is a good place instead of having it be up in the waistband. So yeah, having the spark kind of like in a little pocket too. It also makes it nice for being able to, if the spark loses connectivity and you need to reset it, or you need to plug it into your computer to do another Wi-Fi router or something, you can do that pretty easily. And so yeah, that's like what it looks like when you have it unzipped and unbuttoned with the LED array. And then lastly, batteries. So batteries are the buzzkill of wearables, because you want a big one because you want the battery to last for a long time. And they're not, unless you're a battery engineer or something that can really, like, custom make your own batteries, which I would blow up my house. I don't know about anybody else, but I'm not making my own batteries. The ones you buy are bigger and clunky and ugly, and so you need to try to figure out a good way to put them. And in skirts, my first skirt that I ever made had EL wire, and EL wire is like electroluminescent wire. It's just got this, like, phosphorus that glows when you put electricity on it. And in my infinite wisdom, I had no idea what I was doing. I put the battery pack, like, right by my leg for some reason, and I thought this was I'm like, okay, because I won't be able to sit on it. It'll be kind of out of the way. Forgetting that when I, like, walk or move, I would be hitting that battery thing constantly. And it was really, really annoying. So you want to keep the battery kind of out of the way. And I found that, like, middle of the back, like right here, is good. When you sit down, you kind of have to, like, kind of sit a little forward or whatever, but you can usually adjust that pretty well, and it's a lot better than walking around and having this battery clunk and then, like, way down on your garment. Having it here is a good stable place to put it. So let's see if I can do this here. The Tweetskirt just I bought, like, the world's longest pink zipper and put it all along the back, and then you can just completely unzip it and then put the battery right in there, and it looks like it's not secure right now, but when you're wearing it, it's totally fine. The elastic is strong enough that it holds it to your body pretty well. Yeah, and the voltage regulator is back there too, so, like, both the battery and the little thing to drop the voltage down to 5 volts is both back in that pocket. And so I think I'm way ahead of time, but that's really all I have, and I can answer any questions, or, yeah? So how long does one battery last for? 3 hours-ish, something like that. So I just carry 2 batteries with me. And then I think there's one way you can do it is if you turn down the LED brightness. If you turn it down, it's not perceptible that it's lighter or lower, dimmer, whatever. But it does save a lot of battery. So you can tell by how many amps it's drawing, and then I don't know exactly what you do for that, but there's like you use a multimeter to see how many amps your LED array is drawing, and then you can calculate it out roughly there. But I started doing that, and then I just got bored, so I didn't finish it. But yeah, the 3 hours is good enough. Yeah, well, the pocket. I mean, the pocket has the zippers on either side. No. Um, yeah. Yeah. So the battery. I actually have a picture of this. I could probably do a lot easier. But the data line. There's nothing holding the LEDs in place besides the wire, and the wire is pretty stiff, and so it's not perfect. Which is why if you ever see gaps in the text, I thought about sewing it to some interfacing or something to really hold it, to have it evenly spaced. But honestly, like it never really has been that big of a problem. Just having that line that goes perpendicular to all the LEDs kind of keeps them evenly spaced because, let me go back to, yeah, it's good enough, I guess. So the little blue lines, which are the data lines, those keep it kind of spaced evenly there. And then the red lines that connect up to it is just enough. It's enough to keep it more or less evenly spaced and hold in place. Yeah?
Did you pretty much become like Radio Shack's favorite customer for a while?
There's a lot of people, a lot of Chinese sellers on eBay that probably like me very much. Which is, I guess, like kind of a tip if you're going to get into this. So NeoPixels are cool. Ordering them from Adafruit will get them there in like a week or something. But if you don't mind waiting like 3 weeks, you can spend a lot less money ordering them from eBay. Just make sure you're buying the right chipset, the NeoPixel chipset, which is WS2812, 2812B, depends, whatever. And that takes about 3 weeks, but it's a lot cheaper. Probably not bigger. I want to make so when I went to the Internet of Things Fuse conference a few weeks ago, and I have a friend that has these Christmas lights you can tweet to or whatever, and he interfaced it. He got it to work with Yo, and like where you Yo at these Christmas lights, and it chooses a random color and then displays that color like a random color. And I'm like, I have never thought to use Yo on any. So I want to make a hat. I started working on this and I got really discouraged with it, but like a hat that just says yo and then you yo at the hat and then it just goes like it lights up. I want to make a yo hat. Yeah. For me? So a lot of people ask me that, like making money off of this. And honestly, this thing breaks so freaking much that I really don't want to have to maintain. Like if I could just like build it and give it to someone to do the customer support forever. But I have to know a fair amount about, like, I would love to make these for people. I would love for everyone to have them. But this, array thing is a little weird. It breaks, the data lines break, the power lines break. I have ordered, and was really wanting it to get here in time, but it didn't. Like, they do make LED arrays that are just like a flat panel, and I'm feeling like those are just going to be too, they'll be flexible, but not as flexible as this. But then they'll be a lot more, durable. And I will like to play with that when I get it in, but because that would still be a little bit more, durable. I would feel better selling something like that. But this, like I said, this thing, it breaks. Last time, I think I blew out a spark somehow. I don't know how. But no swimming. I didn't spill beer in it. That would be great, maybe. But anyway, no. Yeah, so not yet, just because the durability is not there. Or if someone else can figure out the durability, then hats off to them. They should make all the money in the world.
Are the current LED strips, are they pretty flexible or are they pretty rigid?
No, these ones are.
They're flexible, yeah, like the ones on the boat. Yeah. Come on.
Like the ones in the boat. No, but I mean like these
Well,
ones.
they're waterproof too.
Yeah, like.
Okay. He's seen my flexible strip.
Yeah, don't break.
I had my flexible strip on his boat.
It's the solder joints that are the lack of durability. It's like, just trying to get the solder to stay is where I have run into the most problems.
So if we tweet you eBay or eBay links, can you say yes or no?
Sure. Well, actually, let's do this. Let's see who. The Tweetskirt is awesome. Okay, we'll see if that works. It should. But should have done that earlier, maybe, instead of just queued up a whole bunch of them. But I'm sorry, what you want it?
So if we tweet eBay links, like, is this the right one?
Yeah.
Would you say yes?
Yeah, I'll give you my business card. You can just email it to me. Anything else?
I missed one. Maybe I missed this part. So is the gradient effect, is that program, can you program that, or is that hardwired? Are those LEDs multi-color, or what?
Yeah, these are all RGB. I'm sorry, I guess I never really covered this, but yeah, the LEDs are all RGB. They can be whatever color you want. I did the rainbow because it was easy and kind of cute, and it's better than being one color. But really, I could like on my server do sentiment analysis on the tweet, and then like have it be green or red, whether they're happy or sad. I mean, I've thought about this, but I just never have really gone into how to make sentiment analysis work. But really, it could be any color at all.
What was it like?
Teamwork. Yeah, it's fair.
What was it like? Because like you didn't like. How did you arrive at that gradient color? I'm just interested in your dev process because I can imagine like, what was it? Did it look perfect at first, or like how was it iterating on the visual look of the actual LED array?
Well, it was mostly size. I mean, like, are you talking about the development of the LED array idea itself, or?
The color specifically, like I know this could be like
No,
or whatever, but yeah, like so there's like what 3 red at the top, maybe like I don't know 7 or 8 and green in the middle, and then like maybe
well, it was supposed to be rainbow, but basically there's this wheel function. Is it working? Oh, nice. Actually, I'll just queue up a bunch of these then. If it's working, I might as well party. Did that work? No. I'm sorry, Substars. You just put I. It was just like one letter. Oh, you're trying to break it. Well, I have it so if it doesn't recognize it as a character, it will just have a space. So someone tried to do some like funky like shrug emoji at me at this party, and it just was like space, space, dot, underscore, space. It didn't really look right.
Yeah, so what if pictures are included? Will that just ignore
Yeah, it'll just,
stuff?
no, it'll just do the, like this is a picture or link or something. It'll just have the URL. I should have it strip out the URLs if there are one, because it's really cumbersome to have the URL scroll across the screen, but you too can take a bath. I think this one will work. I think this will work because I think it's just the HTML part that makes it like that, but I think that will actually have the lesson sign. I was answering a question and I forgot what that.
so the rainbow.
Oh, right.
0 to 255 or something like that.
Yeah, there's a wheel. There's this function that comes in the, well, it's like in every NeoPixel example ever. It's like wheel. You just give it a number between 0 and 255. I just found the even divisors in that and just have it be the various like indexes of the pixels going up or down is what color gets displayed.
Approximately how long total is involved in this?
Well, like I said, there was like a year of me being frustrated with it and just being a big whiny baby and giving up, and then like picking it back up again. For the server part, I mean, that was me working on it a lot. Man, I don't even really know. I could look at my GitHub repo, but you're gonna see like there's like commits and then nothing for like a year, and then like all the commits. So if I had to give a guess, let's just say 40 hours. No, 40 hours is not a lot. I don't know. I really can't figure it out. It wasn't a nice amount of time. I didn't like kill myself doing it, so I had a lot of fun. I could take bathroom selfies. I've spent more time with this. I've spent more time wearing it than I have, and like wearing it out in the world than I did. Well, maybe that's not true either. I will spend more time wearing it than I will programming it. It's a possibility that exists in the world, and I will do it. Okay.
Have you tried different batteries? Have you experimented with different batteries and sizes and?
Yeah, this is a nickel metal hydride, like the MI. Yeah, and I do have a LiPo battery, like the smaller ones, and those ones don't last as long just because they're smaller. But yeah, I mean, like it doesn't really matter. It's just using the T plug in the back, and then I just clip the wires and solder a T plug back on. And then it's just how many amps, it takes. And both of those are fine. It's just since I have such a large pocket in the back and I don't really care, I'll just use the bigger ones and have it last longer. What happened?
It was actually high, and then it.
Oh no.
Well, because it's got a emoticon in it.
Yeah.
Which one is that?
No, it's the one up there.
Sorry.
This one? I thought I did hearts though. I was playing with hearts when I tested it. I guess I didn't. I didn't. I didn't test the hearts enough. I'm sorry. I really thought I did that. Yeah. Well, I'll fix it. That's so bad. I need to. I heart everything. I can't have hearts not work. My God. No, I mean like the elastic in it is pretty good. Honestly, the waistband was really like, if there's one thing I procrastinated on this, it was like the waistband part of it, and so that could be done. But it's pretty, it held. I never feel like it's gonna fall off. And then when I wear it too, hold on, I wasn't prepared for this. So I also sewed up a petticoat and. Petticoat helps the LED array kind of stay out because it's like fluffy and adorable. So having the petticoat there also kind of, I feel like keeps this, I mean, I never really felt like it's going to fall off, but having another like floofy skirt underneath like does help to keep it up.
So for the battery, is it like a voltage and amperage thing that you wouldn't just use like a USB battery pack?
No, I use like a remote, like a RC car battery. And then the voltage regulator, this one only handles voltage, so I just dial it down to 5. But you can get ones that you can dial up the amperage or whatever too. And then I would talk to my dad about what kind of amperage I would need because I have no idea. But whatever this is putting out is fine. So yeah, it's just like a RC car battery. I have like an RC car battery charger that I just have in my room. But yeah, it's not the USB ones would be cool, but I would be afraid that it would take forever for the USB to charge those big batteries back up. Oh yeah, thank you to Arduino MN who I demo to them a lot of this stuff and they love it. And Arduino MN is a really great group. And I found, because I get sick of asking my dad like 10 million questions, and so I've made a lot of friends through Arduino MN that don't mind answering like electricity questions for the 10 millionth time. So I really like that group a lot. It's very, very friendly. All right, well, I guess that's it. Thank you. I do have cards up here if anyone would like to contact me about anything, questions, LEDs or not. But thank you so much for coming.